Uh, welcome to part two of our presentation. Welcome to part two of our presentation. This is TG, your presenter. We are delving into Linux. The part one was just introduction to Linux using the using the using the terminal. In case some people are seeing for the first time, so using the terminal. Let me adjust my position just a little bit. Okay, so it was introducing us to the terminal. Now part two, we're going to look at bash scripting. Bash scripting. Okay, it sounds verbose, sounds technical, more technical. Bash scripting, I'll be using W3 Schools just for my introduction, just for explanations on what is bash scripting. Yeah, W3 Schools. I've been using this site to learn a lot of IT hacks. So, okay, but we're not going to look into the theoretical aspect of this. What is bash? What? We'll do it some other time. But just a basic introduction, like what is bash? Bash is used to run commands and write scripts on Unix or Linux systems. Bash is the default shell on most Linux and Mac OS systems. So, what are we talking about here? We are saying we are now working closer to the hardware of the machine. When we're working closer to the hardware of the machine, we are working closer to the processor, scripting on the shell, which means from the hardware, we've got the kernel, then we've got the shell, then we've got the operating system which we are using. So in this case, we assume that now you now know what you are doing. We don't just allow anyone to work towards the close to the processor, close to the hardware, unless you know what you are doing. Now in this case, so when you talk of scripting, we're now saying you're not yet a guru in Linux, but at least you now know some things. Why? Because you're now working towards close to the processor. You will see as you try to execute some of the commands will be blocked, that you don't have access. Only the super user is allowed to work close to um, the kernel. So it's just an introduction. So basically, here we are going to look into. There are so many commands, as you can see. There are so many commands. Some of them we did already. But in this case, we are going straight into scripting, syntax. So we're going back to the what? We are going back to the terminal as well. We're going back to the terminal. So bash syntax for scripting. Bash scripts are sequences of commands executed by the bash shell. They automate tasks and can be used to perform complex operations. Understanding bash syntax is crucial for writing effective scripts. So we are scripting here. Here are some of the basic rules. Yes, that's why I wanted to start from rules on working on what? On a bash script. Okay. So likewise, I'm using my online virtual machine. I'm using my online virtual machine as opposed to use the what? As opposed to using the actual what? As opposed to using the actual application, console application, which can be installed on your machine. But here I'm just using online tools. So this is my virtual virtual online shell, bash shell. It's my virtual online bash shell. This is called online GDB, online GDB. So I'm using this to run and to test my shells. I'm using this online GDB. That's the one which I'm using for my demonstrations. So then later on in this session, I will use another one again, which will allow us to do the scripting, that is on another platform. But in this case, I'm just using this, which is online, which is just basically for Bash shell or online scripting. Okay, so rules. Here are some of the basic rules for using Bash in scripts. Comments start with a hashtag, and the Bash ignores them. So we need to know that. Then command order. Commands run one after the other from top to bottom. Then semicolons. We also use them for multiple commands on the same line. Okay, we're not wasting time. We are going straight into the what? Going straight into the terminal. Simple, using comments. So we said we use that. We use the what? We use the hashtag. Yes, we use the hashtag. Then you type your statements, and you say statements, they are executed in what? They're executed in order. Okay, so okay, I'm just trying to find a good example. Right. Okay, I think let's just get straight into the scripts so that we save time. So most of the time I will avoid typing some of these things. I will avoid typing to save time, because I just need to have 10 or 15 minutes into this. So I'll just copy some of the scripts, then I'll explain. Okay. All right. So syntax for what? For scripting, I think we've explained this. Then I'm using this online what? I'm using this online. So this online shell. Online Bash shell. Let me just refresh. I don't know what's happening with my laptop. This server is taking time to respond, because it has to be connected on the server for it to be working. Okay, there we go. Then my online, is it working very well? Yes, I think it's working very well. Then I need to save. So I need to share this. I need to share the entire screen. I need to share the entire screen. All right. Okay. All right. So yeah, I'm sharing the entire screen. I'm sharing the audio and the video as well, as we are delving straight into Bash scripting. Okay. Oh, we are 7 minutes already into this, and I haven't started demonstrating this. Okay. So this is the online what? This is the online Bash terminal which I'm going to use. So we said the first thing is we do comments, and they are not executable. Comments, they are not executable. So like this is first Bash shell. Okay, comments are not executable. Then you run your what? You run your script. Then this one, it says hello world. Why? Because I think I've explained the echo already. So we want to insert something into our shell. We use this echo something. So echo hello world, then we are good to go. But the comments, they're not what? They're not executable. The comments are not executed. So this is my what? This is my output window. This is my output window. This is the input. This is the output. Okay. So basically, yeah, it's very simple. Of course, there can be some complications there, but it's very simple. Okay. So then you need to specify before you start working with your terminal that you are going to be scripting. Then you specify the script which you are going to be using. So which statement do we use to specify this? We use what is called the shebang. We use what is called the shebang. But I'm not showing it now. I will show it on part 2 of this presentation. I will show it on part 2 of the presentation. Why? Because we need to declare this. We need to tell the compiler that we are now working with what we are now working with the already. It was compiled already. It's in this format already. This terminal is in this format already. It's designed already, sir. Can you check this? Said main.bash. So it's inside the what? It's inside the bash shell already. So there's no need of compiling. But part 2 of this presentation, I will show you how to compile. I will show you the steps to compile. It's quite a process, but I'll show you on part 2. Just wait, sit back and relax. Enjoy part 1. Then part 2, I will show you how to compile using the using this. I'll show you how to compile using the normal terminal. You have to set up everything. You have to give the permission, for example, to execute the file. Then after that, then you run the file, the bash file. Okay, so I'll show you how to create, how to give the permissions, and how to run the bash file. In this case, everything's done for us already. That's why I'm just cruising on this one, so that on the next part I'll show you how to do that. Okay, here I'm just trying to show you the syntax, the variables, the logic, conditional logic, the if statements, the loops, the for loop, the while loop, then the one or two things, then I'll be out. Then on the other session, part 2 of this, I'll show you how to save, how to compile. Okay, so basically this is very simple. Basically, why? Because there's no compilation, everything is done, everything is done already. Okay, so so this part we'll do it on the in the next video, in the next presentation, using variables, variables in what, in the bash, using variables. You have to declare them, and we said the bash, yes, it executes line by what, line by line. So in this case we're not worried about that. In this case we are not worried about that. Okay, so using variables, like in other programming language, a variable has to be declared first. A variable has to be declared first. Then after declaring the variable, then you use your what? Then you use your variable. So in this case, we are using a what? We're using a string. So name is equal to, you put whatever you want to put. Now I'm putting my name. Name is equal to Tendekai. Okay, I'm putting my name. Be careful, please. Be careful with one thing. When you're declaring these variables, you don't need to leave some spaces, otherwise you'll be in trouble. If you leave some spaces, you'll be in trouble. Okay, my server is misbehaving. Maybe this thing is very heavy. I don't know what's happening here. All right. Okay, what is happening? Normally this server does this. It looks like it's heavy. On the what? It looks like it's heavy on the application. All right, so you declare the variable. That's a local variable. Then you you read the variable using this syntax, echo. Okay, then we want to call the variable. Then I want to say yellow, calling this string yellow. Yellow what? Now I'll call the variable. I'll use the $sign to call your variable. So my variable is what? My variable is the one which I've declared under this name. So that's the name of the what? Name of the variable. So I'm calling name. So whatever was assigned to name, in this case, we assigned this name. We assigned this string. We'll talk about data types later on. And I said, be careful with spaces. Don't leave spaces. So name is equal to, so I assigned this string to this variable called name. Now I want to call the what? I want to call the variable, which is name. So whatever was assigned to name is going to be called out in my what? In my output. Whatever I have assigned to name is called out to output. And some of the compilers requires that we specify, we put this exclamation mark on strings for it to be called, but some they refuse to run. But anyway, it's fine. Let's see what happens. Then we run this. There's our output, yellow what? Yellow variable name. So this is what we've assigned to the variable. I assigned my name Tendekai, so it's saying yellow what? Yellow Tendekai. So that's what we've assigned to the what? To the variable. So it's very simple. It's very simple. So in this case, what is a variable? A variable is a placeholder. In simple terms, a variable is a placeholder. We assign anything to the variable. Here I assigned my name. We can assign anything to this. this variable. But now you need to know what to call data types. But in this case, we go not deeper in this module, but in other modules like programming, they talk about variables quite in detail. But there we just pass, we just show you we just show you the variables which we have. Just show you that we have got this is a string. What else do you have in variables? Variables, what do we have? We have integers. Those are types of variables. We have strings, we have what variables. Where can we find? We have what variables like this one. Number is equal to 42. It's a what? It's a type of a variable. It's a what? It's an integer. It's an integer. Numbers. So these are we've got integers. But let me just say this. There's one problem with Bash. It doesn't recognize floating point numbers. Floating point, those numbers with commas, long numbers with commas, it doesn't accept that. So that's the weakness of what Bash scripting. It only accepts what whole numbers like integers like this one. It only accepts that. But floating point is not yet programmed to deal with that. It's not yet programmed to deal with that. So yeah, these are types of variables. So we spoke about the string. Then we talk about other data types apart from the string. Other types apart from the string. We have got numbers. I think I've said this already. So it's quite a lot. It's quite a lot when you talk about this. Of course, I'm not getting in detail. I'm just showing you what happens if you're working with variables. For example, we are working with numbers. You are working with numbers. This is a program that works with what? That works with numbers. It's a program that works with numbers. Let me just copy this for the sake of time and show you how it works. So we have to delete everything. Why? Because it executes line by what? Line by line. Okay, let me just close the window. There's construction taking place in my background. Okay, there's too much noise. We just close the window. All right, so numbers. So we declare a number. Num1 is equal to 5. Num2 is equal to 10. What is this? Number 1 and number 2. We're going to use numbers in our program. Num1 is equal to 5. So we've assigned a value to our variable. We've assigned a value to our variable. Then sum. What is this program going to do? It's going to add what? It's going to add number 1 plus. That's what it's going to do. Number 1 plus number 2. So then these are just formulas. Then difference is going to what? Working with the different variables. So we do that in Bash scripting. This is a script for working with what? Working with numbers. It's a script of working with what? Working with numbers. Okay. So we're not spending much time on that. Bash operators. What are these operators? These are the operators: equating, equal to, not equal to, LT, less than or equal to, then GT greater than, then GE greater than or equal to. These are operators which will also work within within the scripts. Okay, so where are we moving on to now is logic. Conditional logic. If this statement is true, what should happen? If this is true, then we do that. So we call that logic. In programming. If else statements, if this is true, else what's happening? Or if this is true, this should happen, else everything else is what? Everything else is false. So there we go. This is the basic what? It's just a basic if statement. So we have our condition. Num is equal to 15. That's our condition. Let me just take this and put it in our then explain it inside our shell. We just have to delete everything. Why? Because it will execute everything again. Okay, that's the challenge of this Bash compiler. It compiles line by line. Okay, our condition which we're going to say compare or look into is num is equal to what? Num is equal to 15. Num is equal to 15, or age is equal to 15. So maybe you want to get in a club. So there's a program at the door, at the entrance, which will which will evaluate your age. So you bring your ID. If your age is less than 18, what happens? You are not allowed to enter into that. But if your age is equal or greater than that, then what should happen? Then you are allowed to what? You are allowed to drink, or you're allowed to get into that club. So that's I'm trying to put it in simple terms. If the condition is true, what should happen? The processing, what should happen? If it is true, then this should happen. So if this is our condition, number is equal to 15. So the program is going to get a number. So in this case, we assign 10. So it's going to check if this number is greater than what, or less than what, less than 15. So they need to specify that this one is greater than 10. So it's going to specify that the number which we put is what, the condition number which we declared is greater than or less than what, 10. So this is our program. It's just a simple if statement. Then after that, you are supposed to end your if statement using what, fi. Fi is going to end the what, the if statement. So if you end it with the what, with an if statement. So this one is just very simple. We run this one, then it's going to say what number is greater than 10. Which number? Our 15 is greater than what? Is greater than 1, is greater than 10. Is greater than 10. Okay. What if it's not true? What if it is false? So then we put what is called an else statement. We put what is called an else what? An else statement. An else statement, if the condition is false, what should happen? It should print otherwise. It should print otherwise. So if else statement, our number is 8, then we are going to input what? Input 10. So it's going to check if the number is greater or less than what? Less than 10. That's what this program is going to do in short, basically. So this is our condition. Number is equal to 8. We're going to put 10. 10, is it greater or less than what? Less than 8. So it's going to specify that in our what? In our output. Okay, so number is less than what? Number is 10 or less. Number is what? Is 10 or less. So the number which you put 8 is less than what? Is less than 10. Okay. So this is just a simple if statement. It is just a simple if what? It's just an simple if statement. Okay. These are just simple what? These are just simple scripts. Then loops. Loops, basic loop. What is a loop? A loop is a repetitive what? Is a repetitive statement or a program which repeats itself until a certain condition is true. So it will continue to iterate to go back and check the conditions, until the number is what? Until the number is true, then it exits the what? The loop. So that's a simple what? That's a simple definition of a loop. For this one is a for loop. For, then we specify the what? We specify the condition. Then how is it going to loop? How many times? This one is going to loop 5 times from 1 to 5. It's going to loop 5 times. It's going to loop 5 what? 5 times. It's going to loop 5 times. So what are we talking about in script? We are talking about, instead of doing the same thing repetitively, we can just declare a loop. So it will save us time to do the same thing for a number of times. In this case, we just declare this loop is just a program which is going to print the same thing 5 times just in this program. So in this case, it's going to print 1 to 5. That is the loop for I in 1 to 5. Do what? Iterate, do print how many times? 5 times. Okay, let's just see how this one works. This is a what? This is a loop. This is a for loop. This is a for loop. These are what we call repetitive what? Repetitive statements. It does the same thing until a certain condition is what, or the given condition is true. Else it will loop out, it will stop doing. So this is going to print how many times? 1 to 5. It's going to print out 5 times. Then it gives us what? Gives us output. Okay, so let's see what happens with this loop. It's going to print 5 times. It's going to print 5 times. The iteration is going to go 5 times the iteration. Then it's going to go 1. It's going to print 1, 2, 3, 4, 5. So this is our loop. It's a repetitive statement which will allow a program to repeat some steps a number of what? A number of times. So you specify the condition. You specify the condition on how it's going to run. This is just a simple, but in technical terms, we need to script it in such a way that we need to have what is called an initialization of the loop, then the processing, and then when it's going to what, when it's going to stop the what, when it's going to stop what, the looping function. Where do I have that? Okay. All right, I think I'll look into that. But I'm saying in actual terms, we are supposed to initialize the what? We are supposed to initialize the loop. Then from there, we have the what? We have the execution of the what? Of the statements. Okay, let me check. I think I put it somewhere. Okay, for the sake of time, conditional logic. Okay, conditional logic of edge. I think this we did already. Right, initialized loop, the one which is initialized. Okay, there we go. The one which is initialized. We're not taking time to do this. This will be done in programming. This will be done in programming. Any programming language, they will teach you all these things. Any programming language, they'll teach you all these things. So this is an initialized loop. Initialize the loop for I is equal to 0. So that's the initial statement. That's the initial. We are initializing that it must start from 0. Then the condition I less than 5. Okay. Then what should happen? I plus plus is going to add 1 plus plus. It simply means add 1, add 1, add 1, add 1, add 1. Okay. But we're initializing to 0. Then as long as it is less than 5, then add 1 at a time. Add 1 at a time. Add 1 at a time. I plus plus. Our I, these are what? These are numbers. Add 1 at a time until it's less than what? Until it goes above this. So it will only go up to what? Up to 5. Then after that, it will stop iterating. It will stop printing. Okay, it will stop printing. So it's still the same thing. It's still the same thing. It's only that this is done professionally. This is done like by professionally. Like you have to follow the syntax of the loop, that it has to be initialized, then the condition and everything else. So basically, these are loops. I'm not taking time into this. These are just loops. That's why I'm cruising. These are loops. These are loops. We've got the for loop. We've got the while loop. The while loop does the same thing. It does the same thing. The while loop. It also looks at a condition which is given. We use a counter as well. That is, while this condition is what? While this condition is true, while this condition is less than 5, while it is going to be less than 5, it is going to add 1 at a time. It's going to add one more until it gets to 5. So basically, we've got the for loop, we've got the while loop, which can also be transposed. Instead of saying while this, we can do what is called a do while. So it depends. But these are just what? These are just loops which we play around in what? In programming. So in scripting, we can also do this, especially when we are assigning passwords to the what? To the users, or when the users are accessing a system while the password is correct, log in, else you must log out, or you must give this statement. So you may wonder, why are we doing this? Basically, that's what we're just trying to say. Whilst this condition is true, do something. So I'm giving you an example in Linux. Remember, Linux is good for, basically we're learning this for networking. So if we're going to assign passwords to our users while this password is correct, log in, else log out. Or while this is correct, then it compares the what? It compares the password. Then open the what? Open the machine, or open the resource, or else you get a message that you are not allowed, you are not permitted, or you are not the rightful user of, or you are not the, or you wrong username and password. It will compare the condition which you are going to add, which are going to input. Okay, so it will compare the condition which you are going to input. So it does the same thing again. It's only that now we're using the while loop in terms of using the what? The for loop. Okay. So it's very important. I'm using W3 Schools. Sorry, I'm using W3 Schools for this. You may wonder, where is this coming from? It's called W3 Schools site. Just to explain this, what? W3 Schools. W3 Schools. Okay. Then functions. Functions. We also work with functions as well. Remember what we're trying to do. We are trying to avoid doing the same thing over and over again. We can just declare a function. We just declare a function, then we call that function, then we are good to go. Okay, so we also use functions in what? In base scripting. We also use functions in base scripting. We also use functions. Okay, so this is an example of a function. As you declare a function, and the declaration of a function is followed by what's a function which is declared. Then we have the body for the function. What must happen after that? Then we have the body. If you have some variables, return types, they're explained there. So this is just a simple what? This is just a simple function which we declare. We declare this function. Then what does it do? It's going to print yellow what? Yellow world. It's just a simple function. It is just a simple function. But you must remember the what? You must remember the syntax of a function. You must remember the syntax of a what? You must remember the syntax of a function. The syntax, as you declare the what? As you declare the function, you must use this open and close. Open and close, that's the declarative of the function. Then for the body of the function, open and close curly braces. Okay, I'm just showing the syntax. It's very technical, sorry. That's why I'm explaining this. It's very technical. So you declare the function, you put open and close brackets. Then that's for the declaration. Then for the body, we use the curly braces. For the body, we open and close the what? The curly braces. Open and close the curly brace. Then the statement to be executed by the function or the condition is put in between. So that's how we declare what? That's how we declare a function. It's very important that you understand this what? You understand this this syntax. Okay, I think I put a function already. On greeting, okay, there you go. The function is declared, then open brace, then it's going to call the what? It's going to call a user. It's going to call any name which are going to input inside the what? Inside this function. So let me just take this this function, or I'll use the simple one. Let me just use the simple one. Okay, let me use the simple one. Greet. Okay, greet. It's echo what? It's echo is going to greet yellow. It's just a greeting function. Yellow. Okay. So that's what this function is going to do. It's just going to print my name. It's just a simple function, just a simple function. Then after this, now you call your what? You call your function. If you want to get out, you call your what? You call your function outside the what? Outside the curly braces. Then you call your function. It's a greeting function. You call a function to get your result. Then you run your what? Then you run your application. There you go. It goes yellow tendekai. It's a what? It's just a simple function. What is important is how do you declare a function? Function name. That's the anyway in programming. Anyway, that's how it's the same in Java. It's the same. Even in this scripting is the same. Where anyway, Python, C#, you declare the function, then you call your function. Why is it an advantage? Now you can call the function anywhere else in the program. You can call your function anywhere else in the program. Then it will respond. You can call your function anywhere in the program. Then it will respond. You can call your function anywhere in the program. Then it will respond. That's a function. That's a function. Okay, I think this thing is quite heavy for my the server. It's the server which is doing this. The server, it has to be online. I don't know why it has been doing this, but it looks like it's quite heavy on my on my machine, this server for this. Oh my goodness, is it going to take some time? Oh my God. All right. Okay, just a moment. Let's hope it's going to be fine. Oh, let's hope everything is not frozen. My goodness. Okay, just trying to refresh again. Trying to refresh. Oh my goodness. Oh my God. What's happening? It's frozen. Everything is frozen. Okay, just a moment. The network is good. Is this server? Oh my goodness. Or my laptop. I'm using an i3 laptop. Oh my God. What's happening with this server? Okay, I'm sorry about that. I think my server is the server is heavy. The server is heavy. The server for basic is heavy, or the what is heavy on this. So there are so many types. There are so many types of data. Okay. Then there are so many types, but for the sake of presentation, I'm just showing you one or two. Maybe in case you want to work with so many users, you want to create a group of users who are going to access the laptop. So I think you may need arrays. We may need arrays. So one more last thing, we may need arrays, a type. We may need arrays, it's a data type. We may need arrays. Okay, you may need to work with arrays where you put the name of the users in an array that, okay, in this group, we have got students who are going to be using this machine. So that's how you declare an array, value 1, value 2, value 3, which can be user number 1, user number 2, or student number 1, student number 2, student number 3. Okay, so arrays, we can a data type as well. All right. Okay, so I think now we need to move on to part 2, where we're going to talk about permissions on permissions on resources. How do you give permissions on folders? How do you give permissions on files? So that at least you scripts. So I'm signing out on this. Then let's meet on the next session whereby about what I'll be talking about, creating a specific file, a bash file on the normal on the terminal, then saving the file, accessing the file, opening, editing, and doing all sorts of things. Okay, so let's meet on the second presentation part of this. Thank you so much. Oh, it went okay. 40 minutes. Okay, thank you so much.